we're going to continue on with proofs, also known as verifying trig identities. Today, basically the only new part of today's lesson is factoring as another tool in your trig tool belt. So we'll review the other two things that we did, which was Pythagorean identities and changing everything to sine and cosine. So we'll review all that. But before we do, you guys are just going to be ready to go once I'm done talking. I had mentioned to you guys that we're going, and this open note quiz will be next Tuesday. Okay, I moved it from Friday to Tuesday. I slowed it down. I wanted to give us plenty of time to do everything that's in this section. There's a lot in this section. And you just really want to make sure you take good notes, excuse me, and bring them on that day. Because when you have open notes, you can hopefully find something in there that matches the type of problem that you're about to do. All right? Open note quiz. It's a quiz. Yeah. This will not be on your next test. The next test will be 313, 14, and 15. So that's one test, 313 to 315. That's one test this quarter. And the other test is the mock exam. Mock's like fake, not so fake. Now, I mentioned it a little bit yesterday, so let me go into a little bit more depth about what the mock exam is going to be. This is coming up quick. We had to find a day where there's no school. There's no school next Friday, okay? This is next Friday. Not this Friday, but like 10 days from now or whatever. So, what? Because it's optional. I mean, we're not requiring this, okay? But let me tell you about this. This test is worth 100 points just for completing it, even if you get every question wrong. So everyone will get 100% on the test for showing up, and I'll tell you what the alternative is if you can't show up. And it's going to be treated just like your actual AP Pre-Calc exam will be. The 80 minutes of multiple choice without the calculator, the however many, it's going to be broken down like that. The test booklet is going to look just like it. The answer sheets are going to look just like it. And it's going to be timed out exactly like you will expect on the AP exam. Then I'll be collecting them, and then we will still be in the middle of working on 313 to 315. And then when we're done, you'll get those back, and part of our reviewing in class will be going over the AP exam that you took, okay? In the meantime, after that day, anyone that couldn't come and wants that 100% test will be given a take-home version of it and given an X amount of days to do it, okay? You definitely want to either come to the mock exam, that's preferred, or do the test on your own time because it gives you 100% grade, okay, to balance out with that other test that's going to be sections 313 through 15, okay? So 2 tests, this open note quiz that's coming up, I will make sure I give you a second quiz of some sort so that we have one that can get dropped, and then lots of homework checking and reviewing in class. That's what this quarter is, okay? The mock exam is next Friday. Like I said, there's no school. It'll be here in our concourse. If you want to come for breakfast, we'll feed you from 7:30 to 8, and the exam starts at 8 and goes till noon. So it's giving up some of your time, but we definitely feel, we being all the AP math teachers, because they're all testing on the same day. Calculus classes are being invited, statistics is being invited, and of course, all you guys. So I will have a sign-up sheet tomorrow for you guys to start putting in. I just need to get an idea because we have to buy food, okay? So I need to start getting an idea. But just without me taking names or holding you to it, are there people in this class interested in possibly coming on that day? Okay. All right, I just want to make sure. Like, I'd be really embarrassed if Miss Bunday's students and Miss Springer's students were all here and my AP kids, which is way bigger number than anybody else, didn't show up. Like, how sad would that be if I was here, like, nobody showed up? Oh my gosh, I tried. So I'll try to make up like little slips of paper or something so you guys don't have to like keep trying to remember when it is. And I'll have a sign up sheet of some sort. Okay. So moving on. All right. So let's go. Remember, we sometimes are given these crazy looking fractions where we have to decompose them, break them into 2. That's one of our little tricks, kind of, I guess you could say. We have to do that a lot, actually. And I wanted you guys to have basically the 3 types that you could come across. all in one place where you could go back and look at it during the quiz, when you're reviewing, whatever it may be. Okay, so let's take this first one. And what we have in our numerator is subtraction, and then we have sine x in our denominator. So if I'm going to decompose this into two separate fractions, let's start by making two fractions with a, in this case, subtraction sign in between. And in my numerator, I have 1 minus cosine x. There's my numerator, right? It's the denominator that gets us most of the time, right? If I'm adding or subtracting a fraction, I have to have a common denominator to be able to put them together as one fraction. Remember that. Adding and subtracting, I need a common denominator. So to have gotten from purple to red, I would have had to have sine x in both denominators. And that's it. That's decomposing that fraction. And you might be thinking, just like you did yesterday, maybe, I don't know, like, why is she even going over this? That's not difficult. It's not difficult. But when you put it, you have this problem next to this problem, next to this problem, I'm telling you mistakes are made. And one of the things that I encourage you guys to do in the midst of these crazy problems is doing that backwards checking. Because in my opinion, it's easier to go from this step, purple, to red. So when I'm questioning myself, like, did I separate those correctly? I like to say, okay, if I started with this, what would my answer be? Would my answer be this? And the answer is yes, so I feel good about that answer, okay? In this next one, same idea. I have addition in my numerator, right? So I'm going to separate into two separate fractions with a plus sign. Okay? Could be a minus or a plus in both these problems. And then, so I would have a 1 plus a cosine x in my numerators, right? 1 plus cosine x. Same exact way I started this problem. What's going to be in my denominators over here, though? Sine and the cosine, okay? What do you think a common mistake is that students make on this exact type of problem? They separate them, right? They split it up. They'll say, oh, I'll give sine to this guy and cosine to this guy. But remember, if you're doing my little piece of advice and checking in reverse, if I gave you this fraction, like these two to add together, no way would you have written them as like two, you know what I mean? Like if there was one of these had sine and one of them had cosine, you would say, well, I can't add them together. I would never have been able to go from purple to red if I had separated those denominators, okay? So hopefully by doing that, you would catch your mistake, okay? And lastly is if you have multiplication in your numerator. I'm still going to separate this into two separate fractions with multiplication in the middle. Here's the difference. To multiply two fractions together, I don't need a common denominator. I would only have secant x under one of them. Which one? Well, it doesn't really matter. It would depend on what you need in that particular problem. But you would only put it under one of them. Okay? And if you check it in reverse, let's say by accident, don't write this, this is when I write something in pencil, I'm going to be erasing it. If I put secant x there, I know it's hard to see it, but if I put secant x under both of them and I checked my answer, with multiplication, you multiply the numerators together and the denominators. So I would have had secant squared x here, okay? So in multiplication, when you decompose, your denominator would go under one of your numerators, okay? So you can see how these could be confusing. All right? Pythagorean identities. If you want to write these, I just like having this one paper with everything on it. Yesterday, we did talk about these at length, so if with open notes, you could just scroll back to this page if you wanted to. But we use these all the time, and we will again today as well, okay? So the original, the OG of Pythagorean identities is this guy. Aren't I so cool that I said OG? Isn't that cool? You guys think I'm cool? I know. Can't help it. I'm 51 and I'm just so cool because I hang out with teenagers all the time. Okay, so cosine squared x plus sine squared x. Remember, x can be theta, alpha, gamma, whatever. Okay, it can be any letter. I just use x. Use whatever letter you want. And cosine squared and sine squared can be switched, right? Because it's addition. That doesn't mean anything. But then we can write this two other ways by isolating different words. Like if I want to get cosine squared by itself, I would subtract sine squared x to the other side, right? William, all I did there is I subtracted sine squared x, just making sure you saw that. And I'm calling William out, not because I'm calling him out, but because it doesn't make us way off. All right, and then I could isolate the sine squared x by subtracting the cosine squared x. So, you know, yes, you have to know these. You do have to know these. But if you know the OG, it's easy to come up with the other two. But like I keep saying to you, or I feel like I keep saying because I do this 5 times a day, the more you encounter these problems, the easier it becomes to just remember what they are. Just like everything else that you do in any lesson, studying in any subject. The more you work with it, easier it becomes. Okay? Now, believe it or not, I'm going to do some factoring review. Factoring still tends to be the bane of my students' existence. And then we throw words into factoring and we lose our ever-loving minds. So let's do some quick review of 3 basic factorings. GCF, greatest common factor. If you had, and I'm going to mix them together. I'm going to put some numbers and letters, and then we'll switch it to trig. Because whatever you're allowed to do in regular old arithmetic or regular old algebra, you can do in the new stuff, which is trig. Whatever you could do with numbers and letters, you can do with words. So in this case, we have a binomial. What each side of that minus has in common is an x, right? So x, and then whatever's left over goes in parentheses. I'm not going to write this every time, but I'm basically just dividing both sides by that GCF. And whatever's left goes in the parentheses. I should be able to check what I have in red by doing the distributive property. Okay? By doing the distributive property, and I should get what's right above it in blue. Let me do another one. How about (2x squared minus 2). What's the GCF? 2. What's left over would be x squared minus 1. And sometimes we can go even further and do more factoring. That's x plus 1, x minus 1. And I'm going to review difference of squares again in a second. But sometimes you can do more than one factoring. So there's some numbers and letters all using GCF. I don't think any of you think that that's difficult. But let's throw words into it. And remember, when you see sine x and cosine x right next to each other, that means multiplication. You could put the dot in between them, but you don't really need to. What's their GCF? Sine x. So if I divide sine x by sine x, I get 1. And if I divide that guy by sine x, I get cosine x. Again, I can check any of the reds by doing the distributive property to get what's above it. So whatever's allowed to be done with numbers and letters, I can also do with words. Okay? How about difference of squares? I just did one over here too, but let me make a harder one. Really hard. This is super hard. Oh my gosh. Just kidding. But you should recognize it's going to have a subtraction sign and 2 perfect squares. Maybe a letter that's squared and then a number that's squared. That's a perfect square. And that's x plus 10, x minus 10. Always 2 different signs. Let's skip right to trig difference of squares. It looks weird. Why isn't the squared on the x? I don't know. I knew it at one point in my life. I just don't remember. That's just the way we write it, okay? We square the word. But what that means is cosine squared x means cosine x times cosine x. Just like x squared means x times x, okay? So this is the difference of squares. I'm going to factor it the same exact way I did the one above it. I would have cosine x plus 10, cosine x minus 10. Feels weird, but if you just think back to algebra, which you all are good at, This shouldn't be too bad, okay? And the last one is the quadratic trinomial. These are your chart problems. Now, if you're kind of like, wait, I feel like we've done these before. We have done all of this trig factoring in section 3.10. So if you wanted to go back and look in 3.10, you could see more examples of the trig factoring. I'm just reviewing it basically here. So in 3.10, we learned this stuff, especially this one. And I'm just going to jump right to the trig one. So, no, I'm not. X squared plus 2x plus 1. Okay, so I'm going to do the algebra one first. These are chart problems, if you want to write that. What I call chart problems, whatever method you use, as you know, I don't care. But the question is, what two numbers multiply to get 1 times 1 is 1 and adds to get that middle term of 2? And since there's no number in front of the x squared, I can just say x plus 1, x plus 1, right? 1 times 1 is 1, and 1 plus 1 is 2. Okay, so that's algebra. Let's do the same exact problem, throwing trig words into it. Sine squared x plus 2 sine x plus 1. If you remember back in 3.10 when I taught these to you, I said, well, if it helps, take the word sine out of it and just put the variables in. Then it would have looked like this example. And then in your final answer, throw sine back in front of the words, or sine in front of the letters x. Because our final answer is going to be this exact thing. It's just going to be sine x plus 1, sine x plus 1. You would make your chart and find your numbers, which are the same numbers. It's the same problem, really. And then you would have sine x plus 1 twice. Okay? So anything you can do with numbers and letters, you can do with words, plus some additional ones like these new identities. So back in geometry, when you had to do proofs, you were taught theorems and postulates and corollaries. I know it might give you nightmares to think about all that again, but these rules that you know, if two sides of a right triangle, you know, all those things. You were allowed to use those in your proofs. For us, we use what we call trig identities, okay? The reciprocals, the quotients, the Pythagoreans. Tomorrow we learn the sum and differences. On Friday we learn the double angles. There's a whole bunch of them that we're going to be learning, okay? All right, now so I don't tend to do notes on your own paper. I thought that would be a nice go-to for a lot of review, but I put the whole rest of your notes on page 138. So this is where we were yesterday, same section, just I think it's a different page than we were on. So page 138 in your notes. We're going to do 4 examples, and I kind of just adjusted this page to match. So let's start with A that's already printed on your paper, okay? And then you can write the others, and I'll give you a chance to write them. The first 2 are a tiny bit longer. These last 2 are like 1 step, okay? And then you have 4 homework problems to do, and you should be able to finish them in class, okay? So here's why we learn all these identities and review the factoring and all that stuff and the fractions is because we have to somehow make this left-hand sided mess look like the right-hand side, okay? So the first step in these is the hardest thing. How do I start? That's the number 1 question I get. How do I know how to start? And that's why when I teach you these and I go over these, I tell you what I'm seeing. What I see is this to kind of help you start seeing it, okay? Now, having said that, there are students that will easily see another way of doing it. And that doesn't mean they're wrong or I'm wrong. One of us might have a better or faster way. It doesn't mean either one is wrong. That's what makes grading these quizzes the worst day of the year for me. Literally the worst day. I would rather grade all of your unit circle quizzes because I can do that really fast than grade these. So I'm going to be encouraging you guys to use neat handwriting and show every step because I'm going to have to look at your steps and make sure I understand what you're writing. Okay, so please be nice to me when you write these for me on your quiz, and I'll keep reminding you of that. Okay, so let me tell you what I see. What I see is I'm going to start with the left-hand side because it's the most complicated. It's got the most to work with. So I'm going to work on the left-hand side. I don't touch the right-hand side. Okay, I then say, okay, I have to take this subtraction problem and somehow subtract them. How do I know that? Well, because I have to get down to a single term. So somehow I have to subtract crazy fractions made of words, okay? But we're going to do it. So then I say, okay, to subtract, I need common denominators. So what I'm going to do is, because I write so big, I need to I'm just rewriting this left-hand side right now. I need to find a common denominator for these two fractions. Now remember, common denominator, if I gave you just regular old numbers or letters. For example, if I had a 4 and I had an x, I would have to have the 4 and the x, right? 4 and x would be my common denominator. If this is an x plus 2, I'd need a 4 and an x plus 2. So here, I need cosine x and the 1 minus sine x. If it's in the denominators of your two fractions, it has to be in the denominator of your common fraction, okay? So that's what I'm going to do. I'm going to go ahead and say, I know what my common denominator is going to be. It's going to be those two denominators. And you can write them in any order, right, because it's multiplication. This is just what I chose. I like to put the monomial in front of the binomial. So this is my goal, is to make these two fractions each have that denominator, okay? So let's take it fraction by fraction. So with this first fraction, it's missing the cosine x, right? That's what the denominator is missing. So I'm going to multiply this denominator by cosine x. And I'm allowed to do that as long as I do it to the numerator, right? You can do anything you want to a fraction as long as you do it to the top and the bottom. So now my denominator is good in that first fraction, and my numerator becomes cosine squared x, right? Cosine times cosine is cosine squared, right? Done with the first fraction. Look at the second fraction. I want my denominator to have both of those, so it's missing, let me use red, 1 minus sine x. Right? I can do anything to the denominator, now it's right, as long as I do it to the numerator. So don't look away, look right so you can see. I'm distributing negative sine x to 1 and negative sine x to negative sine x. That's what that is. If you need to go off to the side somewhere and do it, that's fine. If you want to see me do it, that's fine too. Negative sine x times 1 minus sine x. That's what I'm doing. Okay? So I'm doing this times this and this times this. And what I would get is negative sine x plus, right, negative times a negative, plus, and sine times sine is sine squared. Now you're probably thinking, and that would be normal, what the heck? She's making this way more complicated. I thought we were supposed to be simplifying down to secant. This is just getting messier and messier, but we're really close. In this next step, you're going to see the answer, which is just secant x. You're telling me, yes, I'm telling you, that in we're 2 steps away from making this into secant x, and that is, yes. One thing I want you to notice is if you have a bunch of, if I gave you this, x plus 4 plus x, couldn't you add these together and make them 2x, right, in the numerator there? Well, what we have here is cosine squared x plus sine squared x. Do you guys remember what that equals? 1. You say that, Levi? That's good. 1. So look what I have in my numerator, just 1, because that's these two, minus sine x. How fabulous are our Pythagorean identities? I get a little excited about them. They are super, super useful. They are so great at taking a mess, this mess, making it 1. That's lovely, right? So we have 1 minus sine x on top and cosine x times, we haven't done anything to the denominator, but we're about to. Do you see it? Do you see it? You can cancel it out. I'm allowed to cancel 1 minus sine x on top with 1 minus sine x in the bottom because I'm canceling the whole thing, okay? I'm not like canceling sine for sine or like the ones, but the whole binomial with that whole binomial. So you're left with 1 over cosine x, and we're ready to write our answer because 1 over cosine x is secant. And remember what I said yesterday, you can write the secant x the whole way down after that equal sign if it helps you, but you do not have to, okay? Sometimes I feel like it gets a little messy, especially with a lot of steps. So I just keep putting the equal sign, and I know it's carrying through. Now, listen, one mistake I'm very picky about on these quizzes is when you get to this, I see it all the time. Students will stop right here. Don't write this. I'm in pencil, so you know I'm going to erase it. And they'll do this. Yes, that's true, but I don't necessarily know it's true. You would probably laugh, maybe not, at the things I've seen in some of these problems. They try to make it look like they know what it means, like, oh, they'll write like this green step and say equals secant x, as if it does or something, okay? And I get it, fake it till you make it, but the truth is, I need to see all the steps. So when you do the quiz, show all the steps, and your very last step should be secant x equals secant x in this step, okay? Our very last step over here is going to be cosecant x equals cosecant x, okay, just like you see here, all right? So a lot going on there, but that's why I'm exposing you to lots of different problems. This is why I'm skipping around a lot and adding problems to our notes, is so that we see every possibility that I think you could see, okay? All right, we should be writing this next one. And as you're writing it, let me tell you what I see. What makes me attack a problem a certain way is what I'm looking at in the beginning. So I take a second, I don't just dive in. So I see on the left-hand side, similar to the last one, believe it or not, they're just not fractions. I've got some multiplication and addition, and I have to simplify it down to one single term. So somewhere in here, I'm going to have to add those two sides together to get 1. Now, there's no squares in here. And I don't even have fractions to get together. So here I was using some fraction skills, but I do have that one trick in my toolbox here, my tool belt, which is one thing I know I can always do is change everything to sine and cosine. Anything that can be changed to sine and cosine, I'm going to do that. Because a lot of times that leads me to another step. Remember, we don't have a plan necessarily. Let me just speak for myself. I don't have a plan when I start a problem. I do one thing I can do, and I hope and pray that it leads me to another step and then to another step, okay? So I knew I could do that. That was one thing I knew how to do. And then maybe I say, okay, well, let's put these two together, and then I just have something plus something, okay? I'm kind of getting it smaller. So I'm going to put these two together. Okay, this is, if it helps, it helps. Feel free to put a 1 underneath. Sometimes I like to do that, even me. Just kind of helps me see my denominators clearly and stuff like that. I'm multiplying. I don't need a common denominator. So my numerators would be cosine squared x, right? Cosine times cosine is cosine squared x. And then in my denominator, I would have just sine x, right? 1 times sine x plus. I haven't done anything with that sine x so far, and if it helps you, put a 1 under it. Okay, we're getting closer, believe it or not. We want to get cosecant over here. Right now, I'm adding together. I need to make it into 1, and then hopefully something will tell me how I get to the final step. We don't know it at this step. That is normal. You're kind of steering blind, somewhat blind. Okay, this is addition. I do need a common denominator. What would my common denominator be? Sine x. Don't need to do anything to this fraction. And over here, multiply by sine x. Remember, top and bottom. That would get you, there she is again. See how it just all of a sudden it becomes clear. I mean, to Danielle it did. I don't know if other people. But there's the second time you're seeing cosine squared x plus sine squared x. What does that equal? 1. Isn't that lovely? That's 1 over sine x. and we're always remembering, I'm constantly glancing over there to make sure I know where I'm heading. It doesn't say 1 over sine there. It says cosecant, but guess what? I'm there. Yay. Okay? So those were the hardest two, even in the homework, I think. And you have to add, subtract fractions. It's annoying. It should get easier, though. Okay? All right, last two. I think this one's 1 step, this one's 2 steps. Almost done. Yes. Yeah. Okay, so last two, you should be writing these, please. Give me a second. I don't want you to miss a single second of what I'm saying. Okay. I just told you that example C is 1 step. It takes 1 step. And that's hard to believe because it looks kind of crazy, but it's not. It really isn't. Here's why it's almost simpler when there's more going on, because there's still a lot going on this side. So I'm going to work with this side, and I'll tell you why in a second. But it doesn't look like I have to do a whole lot to get to this, because it's not just sine. It's 1 minus 2 sine squared x. Okay, but let's not worry about that. How do I decide which side to work on? Because they both kind of look complicated. And just my brain, I don't see anything here. That doesn't mean there's nothing here for you guys to do. It does not mean that, okay? What I see, though, sharing, is I see sine on this side, I see sine and cosine on this side. And I know a way of changing cosine to sine. I know I can change cosine squared x to 1 minus sine squared x. It's one of my Pythagorean identities. By the way, you might be thinking, and I try to predict what you guys are thinking, like, why isn't she changing that one? Because that is also 1 minus cosine squared x. Well, you could, but you'd have all cosines on this side, and I can't think of a way to go from all cosine to sine. So it makes more sense in my brain to change cosine to sine and then see what I have. But it doesn't mean I wouldn't have made a mistake and had to back up and try something else, okay? So I'm going to change this guy to 1 minus sine squared x. That's all I've done, okay, is I changed that to that. I'm going to bring down minus sine squared x. Do you see it? We're there. Let me remind you, if I gave you this right here, and I told you to simplify it, that would be 1, and then we have negative 1 minus 1, which is negative 2x. These two equal negative 2x. These two equal negative 2 sine squared x. So, I'm going to use this color. So I'm bringing down the 1, and what I have underlined in red would be negative 2 sine squared x. And that's what I have on the other side. 1 step. Yay. You got to remember your algebra. Sometimes it's hard to see that that would equal that, right? It's not super clear. That's why we encounter lots of problems. So when you see that again, or if you see that again, you'll be like, oh, I kind of remember that. It's not brand new. Last one, sine x minus sine x times cosine squared x equals sine cubed x. We haven't seen cubed. Definitely going to start with the left-hand side. And what I want you guys to recognize is we have a binomial here, and we've got like terms on both sides of a plus or a minus. That's a GCF situation, factoring. So look at it. You have a plus or a minus here. In this case, it's a minus, with the like terms on both sides. You can factor it out. What is that going to do? I don't know, but let's see. Okay? So if I factor out a sine x, I'd have 1 minus cosine squared x. And that, my friends, is another one of your Pythagorean identities. What does 1 minus cosine squared x equal? Sine squared, yeah. And when you multiply an x with an x squared, you get an x to the third. So sine, like this is a 1 and that's a 2, right? That's sine cubed x equals sine cubed x. Okay? These are hard. Are you guys finding them a little easier today? Are we feeling a little better? Anybody like them yet? That's okay. Most people don't. All right. All right. 4 homework problems on page 144 is where they start. Same page as we were yesterday, just different problems. Tomorrow we'll be into practice set 2, finally. Tomorrow's a little easier. I know, I'm calling this D3, even though we didn't have a D2 technically yesterday. It was just easier than renumbering everything. Yesterday was notes, homework all together in class. We'll just call this D3. Okay? All right, so again, let me write it here. We're on page 144, D3, 8 through 10 and 14. So I'll do number 8 if we get going. Another crazy looking one. But I'm hoping you guys are looking at that and seeing something. What do you see? I just talked about it. GCF. Yeah. Remember a plus or a minus here with like terms on both sides? Probably a GCF problem. Okay? So that would be cotan squared x. You can't get hung up on where am I going to go from there. Because maybe it's just me because I'm a visual person, I don't see it. I don't see that step ahead. I have to see it written like this, and then it helps me see, oh, another Pythagorean identity. 1 minus cosine squared x, sine squared x. You're not even having to look at your notes for that anymore. You're remembering it now. Okay, so start focusing in. I need to get to cosine squared x. I don't know what else to do except change to sine and cosine. So a lot of times when we have a cotan or a tan in the problem, that's what you're going to do. Okay? So that's cosine squared x over sine squared x. Do you see it? Okay. Hint on 9 and 10, you start by factoring. Difference of two squares, or GCF. There's the first 3. And then there's just one more, number 14, that we'll put up in a moment. Right here. Can you see it? AP statistics. Yeah. It's just it's just math that day.
Yeah, will other classes?
Oh, did I not say that? Yeah. We are inviting the AP Stat kids, AP Calc kids.